10 to the power of 1 is 10 and multiplied by 4, that is 10 into 4, 40. So its value is 40. The representation of data in a computer is usually in binary digits. So this is we have learned in basics. The radix are nothing but base is 8. So it consists of 8 digits starting from 0 to 7. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram PU College, Temple of Excellence, Mysore. Students, let us start our discussion with the chapter 2, that is Encoding, Scheme and Number System. So in this chapter, we are going to learn the different number system and conversion from one number system to another number systems. Now, in the next slide, the weightage of the chapter, total weightage is 9 marks. Here, 1 MCQ and 1 3-mark question and 1 5-mark question. So, total weightage of the chapter is 9 marks. Now, in this chapter, we are going to cover the topics representation of data and information, number systems, and number system conversions, representation of negative numbers, and binary addition and subtraction. These are the different topics to be covered in the chapter data representation. Now let us start our discussion with the introduction. In digital computers, data and instructions are stored in computers' memory using binary codes. Using binary codes, it is represented by binary digits 1 and 0. This is what we have learned in our introduction to computers. There we have learned that computer is a digital computer or is a digital machine. So data and informations are stored in computer memory in binary code. Which are the binary codes? Here 1 and 0 are called binary codes. These two are called a bits, and combination of bits forms a binary code. So, in computers, all data, informations are stored in the memory in digital form. The data may contain digits, alphabets, or special characters, which are then converted to bits understandable by the computer. As all of us learned that computers knows only a machine level language, or it is a language of binary codes. But our data may contain digits, alphabets, or special characters which we can understand, and same cannot be understood by a machine or a computer. So, for that reason, the data what we are going to enter, it has to be converted to bits. In the sense, so it has to converted the data into machine readable form or machine understandable form, that is computer. So, that is by the computer. So, all arithmetic operations are performed using binary bits or binary digits. So, here the basic concept here is computer is a digital machine. So, it works based on the binary numbers 0s and 1 or with the combination of binary codes. And here, whatever the data information, it has to be converted into computer understandable form, and all operations are done by using binary digits or 0s and 1. So this is the introduction to the chapter data representation. Now next concept is number system. A number system uses well-defined symbols called digits. The values of digits depend on the position in which they appear in the number. Now, if you talk about our day-to-day mathematics or day-to-day life, we are using numbers or we are using digits from 0 to 9. So, 0 to 9 are nothing but a type of symbols called digits. So, the values of digits depend on their positional value of the or its place value, that is number system. And number systems are basically classified into two types. They are non-positional number system and positional number system. So here students, so what is a number system? A number system is nothing but we are representing all the numbers or digits by using a symbol or called digits. So here, and there are two types of number system. One is non-positional number system and positional number system. Now let us see this one by one. What is non-positional number system? The non-positional number system consists of different symbols that are used to represent numbers. So the first point is non-positional number system. They consist of different symbols to represent numbers. And here Roman number system is an example for non-positional number system. So here now all of you know what are Roman numbers. Just look at the example. Here we represent this symbol, it will represent 1. And here V, this is represent 5. And this is X is equal to 10. See, and here L is equals to 5. This one you might have learned in your junior classes, isn't it? So if you look at these examples, so here X stands for 10 and here V stands for 5. Each of these symbols represent a value irrespective of its position. In this example, there is only one position, and here there are two positions. I mean there are two digits. Here X stands for 10. So here, irrespective of digits, irrespective of its position, so it gives a value. For example, here X equal to 10. And similarly, if we talk about L equals to 50. Here also there are two values, there are two digits, 5 and 0. But here L stands for 50, that is one number, and X stands for 10, it is one number. So this number system cannot be used effectively to perform arithmetic operation. Means non-positional number system. Here example is Roman number system. So in this Roman number system, we use different symbols like 1 or it is I, V, X and L, and irrespective of its position, it gives a value. And here we cannot use this effectively for arithmetic calculations or arithmetic operation. So this is non-positional number system. Now let us see another type of number system, that is positional number system. The base or radix of a number system is the total number of digits present in any number system. So in this example, I mean in positional number system, see we have something called a base or radix of a number system. So what is a base or radix? It is nothing but the total number of digits present in any number system. So now we are going to learn with different examples. Now every number is represented by a base or radix is called X. For example, X is a base which represents X digits. Now decimal number system, binary number system, octal and hexadecimal number systems are some of the example for this type of number system. So here these are 4 types are example for positional number system. So here in our day-to-day life, we are using decimal number system. So decimal number system is a standard number system what we are using in our day-to-day life. So now let us see these systems one by one. Decimal number system. Now this is the most commonly used number system in our daily life. That's what I have told you just now. In our day-to-day life, we are using decimal number system. It has 10 numbers. Deci stand, the meaning of the word deci is nothing but 10. So it has 10 numbers starting from 0 to 9. Hence it is called, its radix or base is 10. So first one is decimal number system. So what is decimal number system? Decimal number system, the base is 10. Radix or base is 10. So as what you have seen in our previous slide, in your previous slide, we have told that every number system represented by the base or x which represents x digits. So similarly, in this example, as the radix or base is 10, so it consists of 10 digits starting from 0 to 9. So now look at the example. Now see, this is what we call as positional number system. Now look at this. For example, I want to represent number 54276. Here 5, 4, 2 and 7, 6. Actually the 542.76. Suppose if I want to represent 5, 4, 2.76. This is our normal number, what we do in our day-to-day activities. Now here 542.76. Now you have learned in your junior classes what is the position of this. Now I'm talking from here 542 point. This is from point, this is after decimal point, this is before decimal point. Now in this 2a is in its, we say units position. 2a is in its units position. Now 4 is in tens position and 5 is 100 position. So this is what we're talking about, positional number system. So each digits or numbers are represented with a particular position. So in this example 542.76, here 2a is in units place, 4a is in tens place and 5a is in hundredth place. Now how do we write this? Because here the radix is 10, it is 10 to the power of 0. First one is 10 to the power of 0, 10 to the power of 1 and 10 to the power of 2. This is our positions. And look into this. Here, what is the value of this? 10 to the power of 0 is always 1. So here 2 into 1, that is 2. We represent this as 2. And here 10 to the power of 1 is 10. And multiply by 4, that is 10 into 4, 40. So its value is 40. And here 10 squared, because its position is 2, 10 to the power of 2 or 10 squared. So here 5, 10 squared is 100 and here 5 into 100, 500. So this is the positional value of 5. Similarly 40 and 2. So next one is after decimal point. This is from here we start with -1. Here before decimal point we start from right to left. This is 10 to the power of 0. But here after decimal point the positions start with 10 to the power of -1. In this example 10 to the power of -1, 7 and this is a number, and this is 10 to the power of -1 is 1 by 10 into 7, this is the value, and this is 6, this is 10 to the power of -1, this is 6 is 10 to the power of -2. So 10 to the power of -2 is 1 by 10 squared, that is 1 by 100 into 6, that is 0.06. So this is how we represent numbers in decimal number system. For example 542.76, this is how we represent in our mathematics. So this is decimal number system. So decimal number system, a type of number system where the base, the radix is 10. So means it consists of 10 digits from 0 to 9. So this is what we have learned in our, even you might have learned in your junior classes. These are the positions of each number or digits. It is called as positional number system. This is example. Now let us see one more type of number system, that is binary number system. Binary means 2. So here the representation of data in a computer is usually in binary digits. So this is we have learned in basics. So computers or data informations are represented in computers with binary codes. Hence the base is 2. Base is 2. Binary, bi stands for 2. So the radix or base is 2. So the positional value are expressed in powers of 2. So positional value expressed in terms of 2 because the base is 2 in previous example, the radix is 10. We express the positional value with 10 to the power of 1, 2, 3 and so on. So here in binary, the radix is 2 or base is 2. We represent or we express the values in powers of 2. Now consider an example now. In this example, 1, 1, 0, 1, 1, 1, 0, 1. See, this is an example now. In this example, observe this. These binary digits or binary number system consists of only two values, either 0 or 1 or combination of 1. So that is number system, binary number system. So if you look at the example now, here this is 1, 1, 0, 1, 1 and 1, 0, 1. This is the decimal point will be here. So if you look at the number here, all digits or numbers are having numbers either 0 or 1 because those two are the numbers available in binary number system. So all the values has to be represented with the combination of zeros and 1. So in this example, look at the example now as what you have seen in this in the statement. We are expressing in powers of 2. Again, starting from here, this is 2 to the power of 0, 2 to the power of 1, 2, 2 to the power of 3 and 2 to the power of 4. So here there are 5 digits here. Then after decimal point, we have 1, 0, 1. There are 3 digits. So here that is 2 to the power of minus 1 and 2 to the power of minus 2 and 2 to the power of minus 3. So here if you convert into, look at the what is the positional value, and here start with 2 to the power of 0. 2 to the power of 0 is 1. So this is 2 to the power of 0 is 1. So 1 into 1 is 1. Now here 2 to the power of 1 is 2. 2 to the power of 1 is 2. 2 into 1 is 2. Here this is 2. And here this is 2 to the power of 2. 2 to the power of 2 is 4. And here the value is 4 here. Now 2 to the power of 3, that is 8 here. So this is 8 into 1 is 8. And 2 to the power of 14, that is 16. 2 to the power of 14 is 16. 16 into 1 is 16. Now look at the digits after decimal number, after decimal point. See here 2 to the power of minus 1, it is 1 into 1 by 2. It is 1 by 4. 2 to the power of minus 2 means minus 4. Nothing but 2 to the power of 1 by 4. And it is 2 to the power of minus 3 means 8. That is 1 by 8. So if you multiply this, you will get these are the values. So this is how we represent the digits in binary number system. These are all the positional numbers or positional values, or we express with 2 to the power of x or 2 to the power of values. So this is binary number system. Base is 2. There are two numbers, zeros and 1. All in data, all the values or numbers are representing with the help of only these two numbers, zeros and 1, or with the combination of zeros and 1. Now let us move on to next number system, that is hexadecimal number system. Hexadecimal stands for 10, hexa stands for 6. So hexadecimal is to the base 16. So here this number system has 16 digits. It has 16 digits, and starting from 0 up to 9, and after 9 we represent A, B, C, D, E and F. So from 0 up to F there are 16 digits. So even A has a value, B similarly B, C, D, E and F. So hexadecimal number system, it has 16 digits, means the base or radix is 16. So what are the 16 values? It is from 0 up to F. Here 0 to 9, we know that. Then we represent 10 in hexadecimal number system with A. So A stands for 10, 11, 12, 13, 14, 15 respectively. So the radix is 16. The base is 16. The positional values are expressed in powers of 16. In decimal number system, we express it in powers of 10. In binary number system, it is power of 2. And similarly, in hexadecimal number system, we express the values in powers of 16. The digits A, B, C, D, E, F have the decimal equivalent 10, 11, 12, 13, 14, 15. Here A stands for 10, B stands for 11, this is C for 12, 13, 14 and 15. Now look at a small example here. Here digits 5, A, F, D. This is 5, A, F, D. Here this is a hexadecimal number system. If you look at all the digits, so this digit 5 is within the limit or it is between 0 to F. This is A. A has a value F and D. So this is an example for hexadecimal numbers. And if you look at its positional values, and here first one is F, 16 to the power of 0, 16 to the power of 1, 16 squared. And here after decimal point, they have one digit, that is D. It is 16 to the power of -1. Now let us move on to next slide. It is octal number system. So octal number system, octa stands for 8. So here the octal number system has 8 digits. 8 digits, and which are all those 8 digits? Starting from 0, 1, 2, 3, 4, 5, 6 and 7. Its radix is 8. So here the radix are nothing but base is 8. So it consists of 8 digits starting from 0 to 7. The positional values are expressed in powers of 8 as we have seen in our previous number system. For example, it is 234.56. If you look at this example now, in the example 234.56, and here 4, it is 8 to the power of 0, 8 to the power of 1 and 8 to the power of 2, and these are values. And here this is after decimal point 8 to the power of -1 and 8 to the power of -2. So these are all the positional values and weightage, and these are the values. So this is octal number system. Octal number system is the base is 8. So in this number system, it has 8 digits starting from 0 up to 7. And this is how we represent the octal number system. If you observe, all these digits are within the limit or between 0 to 7. So all these digits are between 0 to 7. So this is an example for octal number or octal number system. Students, now so far in this session, we have learned the different types of number system. One is positional number system and non-positional number system. And Roman number system is an example for non-positional number system. And under positional number system, we have learned the basic definitions of decimal number system, binary number system, octal number systems, and hexadecimal number system. Students, let us continue our discussion in my next session. Thank you very much.